what I do want to talk about and share with you here are some thoughts related to data ethics in the context of a data scientist's work, meaning to think about an appropriate flow in the context of data collection and analysis. And, well, I guess I just said I would zoom into the more narrow space, but of course, the products that data scientists create are at a larger scale. And in particular, when we think of the many statistical efforts that are going on right now to measure and communicate the progress in achieving the Sustainable Development Goals, whether this is creating sustainable communities or fighting poverty or providing decent work. Underneath sits a lot of operation that has to, and data scientists and statisticians that have to make decisions which data get used in creating these metrics, how are data processed and how our results are shared, and how are data shared between communities so that others can do similar activities. The plot that you see on the left here moving heavily is a plot that is created by Statistics Netherlands, which is the National Statistical Institute of the country of Netherlands. And they cooperate with telecommunication firms to get cell phone data information and can, with that, visualize here nicely the commuting patterns between your home and the work environment. But if you lift the hood, you can imagine that a lot goes in there, the agreements of the telecommunication companies to share such data, the worries that in maybe less democratic countries, such data could then be used for other purposes and the like, right? So the data scientists have to be involved in these discussions around ethical use of data and how we want to do this. And they have to do this at every step of the way. They have to think in that way we just discussed about the input data. They have to make such decisions and consideration in the analysis as well as in the sharing and communicating of the output. And it often, well, most curricula don't have that in it yet, because we sort of assume there's one right way to do a regression model or to run a machine learning algorithm, but really it's humans along the way and humans making decisions that are more or less appropriate. These can have results that reflect back into society too. For years I had fun sort of using Google image search with the search term university professor, which is gender neutral in English. And I got a less than gender neutral response back in the first 25 search pictures. And that's not uncommon, and it's not Google's fault. And it is a combination of the training data they have and what's relevant and what people click on. But what is interesting is that, as I mentioned, there can be decisions made that results are displayed differently. And this decision was made between July 15 and July 19, because a few days after the same search resulted in a completely different picture. And there has been a wonderful team at Google who really took that to heart to make sure that these algorithms, or the results of these algorithms adhere or to fairness norms and look at ethical principles in what data and results should be displayed. Now, anyone working in academia knows that this might also not be a true reflection of society. Even so, this panel is quite diverse. Many universities are not, and certainly not the kind of gender split we see here, right? So there too, as consumer of these data, we always have to think about what decisions are made, even if we do like the result, as I did like this one here. What is key to know is that rarely are we, when we use data, in a situation where we have a census, right? I mean, across the board, and here for us in Germany, the 2010 census had the ambition and hopefully succeeded in really counting everybody, right? So data is available from everybody and can be used. And then any ethical decision that has to be made is on, maybe transformation of the data to certain results. But in other situations, when we think of data streams that come from social media postings, data streams that come from medical records, data streams that come from our Fitbit devices and what have you, we do not have a setting in which we have data from everybody. We have systematically data missing and random missingness too, right? Devices sometimes might not work, but the research we have done showed clearly that it's not just random missingness. It's, data might be more likely to be missing from people that have devices with older operating systems, right? Elderly people might not wear the Fitbit devices and can't share their health data with the health authorities to learn quickly how COVID is evolving, and might, with any technology that is developed out of reading out these data, may be disadvantaged. And those examples, I'm spitting them out here without them being used in practice yet, but we have seen this lack of data resulting in technology being produced, for example, in the context of face recognition, where, where when you closely look at the different prominent face recognition systems, or at least in their state 3 years ago in 2019, this study was done, that major players in face recognition systems worked beautifully for males, less so for females, but definitely less so for females with a darker skin tone. And, one of the reasons why this might be the case, or is likely to be the case, is that there were a lot fewer training data available for certain subpopulations. And that's exactly the kind of missing data problem that I mentioned before. So when an analyst is dealing with data, she has to not only know a lot about the input stream in order to, be able to do the entire analysis task in an ethical way, but as I mentioned, also needs to know about decisions in evaluating the algorithms that may or may not lead to inequality among groups. One prominent example that's on many people's mind, and certainly important in a lot of countries, is credit scoring. And here two young researchers from CMU did a wonderful little study where they showed the accuracy rate, or the acceptance rate, I should say, for machine learning model when predicting credit scoring. So, the higher the score, the more likely it would be acceptable for that person with these characteristics to receive credit. And they compared different models, those with and without marital status and race, included those other small and full models on the bottom. And then they looked at the different models when evaluating them. Overall, they split this up by different education groups, and within education groups by age and so on. What this picture shows us, without going into all these details, is that the result, whether and to whom the loans should be given, and how well sort of the modeling, the large disparities between gender groups in some instances, but not in others. And it varies on how you design the model. So if you just look at this middle panel here, whether or not you include marital status and race, for this age group of those with more than high school education that are married and in sort of a middle age range, it's a gigantic difference, because the loan likeliness is even reversed between males and females, and the gap is much larger in the smaller model in the full. So that means there is an enormous responsibility on the data scientist to decide what should go into these models. How do we want to structure the modeling process? Which features are we including and which ones do we not? My colleagues here in Bavaria from the Bayerische Rundfunk had a beautiful little AI display on their website, and showed this experimentally with a job and candidate applying for a job with a little video clip. And the only difference, the algorithm applied here was an algorithm that scored the job candidate by the big five. So down here in German, openness, conscientiousness, extraversion, and so on. So the big five categories, and the yellow and blue lines are the scorings along these 5 dimensions. And what you see is the blue line displaying the profile according to these psychological characteristics for the video on the left, and the yellow line, the video on the right. What you can't see here is that the absolutely only thing that changed in these videos is whether there's a picture in the background or not, right? With the one with the picture looking more conscientious, so I put some pictures behind me today here for this lecture. But, you know, you see that little things, you know, get picked up by the algorithm that might have nothing to do with what you want to score and can mislead the resulting judgment, in this case, the classification into these categories. And that, of course, is not what we want, right? And that is something that, you know, requires a set of awareness of the fragility of some of these models with respect to the composition and quality of the input data and likely, you know, causes to be led astray. In general, when we think about data use and data sharing and missing data, obviously the term privacy comes up a lot, right? And we do know that people's willingness to share their data and make them available does vary depending on the context. Helen Nissenbaum, a philosopher from Cornell Tech, has written about this prominently in her book, Privacy in Context, which I can highly recommend. And we implemented her theory in some experiments that we did. We proposed vignette studies to respondents. And vignette study means they get a little scenario that you can read here up top. And there are several sentences of information, for example, what kind of data gets collected and who will use the data, what kind of data type is used, and what should be done with the data. And we varied experimentally whether this was a health context, whether we ask about location data, or whether we ask about energy data. And well, the health context actually happened to be about using data from mobile devices and the like, smartphone data, to defend or to fight an infectious disease like a pandemic in the solution now, and to develop a solution against the containment. Now, it so happened that we asked this actually in 2019, so not during COVID, but before COVID, which gave us the beautiful opportunity to then repeat the study and compare the results doing this during the COVID-19 pandemic. What you see in yellow are the answers up here to non-health data and health data from 2019, and then overlaid in purple the data from 2020. And what was very interesting for us is that the shift here of those that thought it's not acceptable to use data for this purpose in 2019 compared to 2020, both of those where we asked the same people twice, which would be the lower panel, and where we ask different people, which is the upper panel. What's the lesson for us here is that we all, when we know data is used for, when we can understand the data use, when we know it's used for a good cause, and you know, there's transparency on that use, then there is willingness to share such data. So, you know, shielding all the data from using, that's not what we are advocating at all, but to think about data being used in context and being used in context appropriately. So if that can be communicated, then hopefully we can avoid those blind spot and missing data problems that I mentioned before. To create more transparency, obviously, we need a lot of people who help, you know, with endeavors in creating infrastructures where one can see what data is used and how data is used. And we recently built such a consortium here as part of the German National Research Data Infrastructure called BERD at NFDI. This is an initiative for business and economic and related data, led by the University of Mannheim, and with various partners from other universities and infrastructure. What is the idea? Well, in order to create trust and in order to make transparent all the many decisions that have to happen along the way in the data analysis process, we do need to have a way to have one platform where domain specialists, those that know, well, wait a second, you know, maybe the proportion of males and female instructors is not what you're showing here. And data scientists who build the models to learn out of images what gets displayed, where they can interact jointly look at data, jointly look at code, jointly look at what models have been used. And likewise, when a domain scientist works on this, that, she can be informed what is good code, what are decisions others made when analyzing these data, so that there's more exchange between the communities and allows for more ethical use of the data. This is important because we do want, this kind of transparency not just happen within the research community, but also when we think about the output that we create ourselves. And you can imagine a system like this on a larger scale where all government use of data happens in secure environments where others could maybe look who got access to the data, who shared data with what. We try to build such an environment in the US and have 14 federal states right now that are participating in this endeavor. They train their people in the secure environment, always with an eye on sort of ethical use of data and adhering to privacy. But it also provides the possibility then to create transparency on the code being applied to the data, the decisions being made along the way, because everything happens in one environment that can be accessed via a data stewardship model. I mentioned there are several states, but of course within these states there are a lot of different agencies that participate in this endeavor, and our hope is to get similar traction in Europe and build environments in which we can jointly and cooperatively can work on the data, adhering to the ethical principles along the way. One framework that we found to be very useful in this context is to think of the 5 safes, where safe projects can be defined so that data aren't used for purposes of inflicting harm on people, where the people that conduct these projects are vetted to be safe people, where the setting itself, the environment, is secure, where the data is shielded and can't just be downloaded, and where any export of the data would be going through a disclosure review control system, so that we do not need to worry about improper data leakage. So if you're interested in these pieces or anything else, I'm happy to answer questions offline later on, and thank you for listening.